All right, welcome. So today we're talking about correlation. So basically what we are looking at is how to measure the relationship between two different variables. So if you notice, the easiest way to do this is to do a scatter plot where we put one variable on one axis and the other on the other. So one being your x, one being your y. Plot all the points, and basically you're going to look for a trend in the dots. So if we notice in this first example, basically as we move from left to right, the points are going up, so this is going to count as a positive correlation. In the next example, the dots are slowly moving down. It's going to be a negative correlation. This third example, the dots are sort of all over the place, so we would say that there is no correlation because they don't appear to be moving up or down. When we talk about the strength of the correlation, basically we're talking about how centralized the points are. So for a strong correlation, all of the dots are going to be relatively close to the middle. For a weak correlation, they're going to be pretty much spread out, and then moderate, of course, will be in the middle. So let's look at an example. As we go through some of these, we're kind of looking for our trend, right? So if we notice in this one, it's moving up, so this is definitely a positive correlation. The dots are fairly spread out, so we can either call this a weak or a moderate. So I'm going to go with more of a weak correlation. And we notice that the line that sort of went through the middle is in fact a straight line, so we can call this a linear relationship. All right, so for B, dots are moving down, so it's a negative correlation. They appear to be fairly straight, so that's going to be linear. And if we look at it, the points are fairly tight, so that's going to be a strong correlation. For C, the dots are all over the place, so there is no correlation. And then Y is a good example of dots where the line sort of bends, right? So since this is more of a curve than a line, we can still call it a negative correlation, but it is not linear. And we would say this is fairly strong. So I'll leave E and F for you to do, as well as number 3. So in this one, you're going to make your plot, check the correlation, right? Plot the points, look at how the pattern. Okay, so the line that runs through the middle is your line of best fit. To do this, we find a regression, which basically means that we're going to draw the line, and then we would go through and figure out how far the points are from the line you drew, and take an average of that distance, and that would be your line. So you kind of want to find some points that are above the line, some points that are below the line, and use that to sort of estimate the line's slope, and then from there figure out the y-intercept. Once you have your line, what you're going to do is look at the correlation coefficient. So the correlation coefficient, the variable we use is R, tells us how well that line fits the data. So what we're going to do is sort of look at the range of values. So the highest you can get is a 1, the lowest you can get is a -1, and then 0 means there is no correlation. Anything over here gives us a positive correlation. Anything over here gives us a negative correlation. So it doesn't matter what the number is, if that makes sense. As long as it's positive, it's a positive correlation. It could be 0.1, it could be 0.9. Same thing with negative correlation. calculate the R, we're going to have to use one of these big complicated formulas. So what we need to know is what each of those things means, right? So the X and Y are the lists. The ones with the bar over it tell you your average. And the N is the number of terms. Also, when you see this guy, it means sum. So now that we know how to read the formula, we can plug everything in that we need based on our list. So if we look at this example right here, I got 3 points. So what I'm going to do is make a table. X's and Y's. I said I need an X squared, I need a Y squared, and I need the X times Y. So I'm going to make 3 more columns. So let's say we do X, Y, so we're just going to go through and multiply. So 3, 8, and 15. Oops, misread that. Got ahead of myself. So 2, 6, and then 12. So then I need an X squared. So that's 1, 4, and 9. We need to square all of our Y's. 4, 9, 16. And then notice we need totals for all 3 of those. So the sum of X and Y is 20. The sum of X squared is 14. And then the sum of Y squared is 29. It looks like the last thing we need is to know N. So basically, how many points did we have? There were 3, so N is 3. So now all we got to do is plug in. So I'm going to take the total of X times Y minus the number of terms. Then I'm going to take the average of X. So to get my average, again, add them up, divide by 3. So X bar is 2. Y bar is 3. And then we're going to plug in on the bottom. We need 2 square roots, so we need the total of our X squared column, so 20. 3. And then I'm going to square the average, or take the average of X squared. So if I do that, 1 plus 4 plus 9, divided by 3, so it's going to be 4.6. Oops, did that in the wrong order. Sorry, we're just going to square the average of X. The average of X was 2, so 2 squared. Plug in here. So again, the total of Y squared was 29 minus 3 times 3 squared. And then I would type all that in, enter, and I should get 1. So we notice the line was perfectly straight. All the points were exactly on the line, and they were positive. So we have a perfect positive correlation. Okay, the next term is the coefficient of determination, and that is basically just r squared. So when we square the r, we can use that to determine how strong or weak the correlation was. The only reason we're squaring it is because we want to ignore the negative. Basically, think of it like we're comparing variance instead of standard deviation. Again, this chart will sort of walk you through the different ranges to determine what counts as weak versus what counts as very strong or moderate, all that good stuff. So for this one, what we're going to do is walk through the calculation again. Right, you're going to use the same formula you just used. You're going to get your r, and then all you're going to do is square it. And you're going to tell from that how strong it is. So instead of writing the whole thing out again, I'm just going to do it on my calculator. So if you do it correctly, r should equal 0.9977. If we square that, you should get 0.995. We notice that anything from 0.9 to 1 is a very strong correlation. So in this table, x and y have a very strong positive correlation. All right, that's all for today. I'll see you next time.